The topic for this video is looking at the position, velocity, and acceleration functions. And if you recall, we talked about the position function before. The position function is s of t. And if we take the derivative of the position function, we come up with the velocity function. And if we take the derivative of the velocity function, which would be the second derivative of the position function, we have the acceleration function. This will tell us the rate at which the object that we're looking at is accelerating. So these are the three main functions that we're going to focus on as far as using our first and second derivative. And the example that's given to us here is the velocity of an automobile starting from rest is given by the function below, where v is the velocity measured in feet per second, and we want to find the acceleration after 5 seconds, or at 5 seconds. And the velocity they give us here is 100t divided by 2t plus 15. So for this example, if we're looking for the acceleration, then that means up here, to find the acceleration, we need to take the derivative of our velocity function. So if we look at our velocity function here, how can we find the derivative? So that means the acceleration is going to be equal to the derivative of our velocity function. And do you have any idea how we can take the derivative of this particular function? Well, hopefully you can see that it's obviously we're going to have to use the quotient rule because we're dividing here. And recall the quotient rule says that we're going to take the bottom function, 2t plus 15, and multiply that by the derivative of the top, which would simply be 100, minus the top function multiplied by the derivative of the bottom function, which is simply 2, and all of this is divided by the denominator squared. Okay, then from here, we can just simplify this. For example, we could distribute the 100, and we end up with 200t plus 1500 minus 200t. And for this example, I'm just going to leave the denominator. I'm not going to worry about squaring the denominator. So from this, we can determine our acceleration. Once we simplify this, 200t minus 200t is simply going to be 1500 over 2t plus 15, the quantity squared. Now, given this function, we want to determine what is the acceleration at 5 seconds. So we're simply going to plug 5 into our acceleration formula. So we want to evaluate the function at 5, and we end up with 1500 over 2 times 5 plus 15 squared. And if you perform the calculations here, you end up with an answer of 2.4. And my question here is, if it's 2.4, if this is acceleration, what will be our units for this answer? Well, if you recall up here, it says velocity is measured in feet per second. So then that means here for acceleration, our units would be, we're accelerating 2.4 feet per second per second. So what that really means is we're accelerating 2.4 feet per second every second. And another way of writing this would simply be 2.4 feet per second squared. Okay. Now, for example, if we wanted to find the acceleration at, let's say, 10 seconds or 20 seconds, you could simply plug 10. For example, if we said, what's the acceleration after 10 seconds, we would simply plug 10 in, and we would have 1500 over 2 times 10 plus 15 squared, and you would end up with, I believe, an answer of 1.2 feet per second squared. So you can kind of look based on these two answers. At 5 seconds, we're increasing or accelerating at 2.4 feet per second squared, and then after 10 seconds, at that time we are accelerating at 1.2 feet per second squared. And let's see what's happening at 20 seconds. Well, if we plug 20 in, we end up with 0.5 feet per second squared. So you can actually tell here it looks like your acceleration is decreasing here as we go from 5 seconds to 10 seconds to 20 seconds. So let's review again. When you're dealing with your position function, if we take the derivative, we end up with our velocity function, and you can take the derivative again, and you end up with your acceleration function. So these are your three important functions as far as position, velocity, and acceleration that you should be familiar with